we are going to discuss the reaction of enamines plus alkyl halides. So let's start with making our enamine, just to be sure that that's fresh in our mind. So enamines come from carbonyl compounds and secondary amines. And you might run this reaction in something like methanol. Regardless of what solvent you use, you are going to lose water. You need to remove water from the reaction, and that will make our enamine. So to do a reaction of an enamine with an alkyl halide, you need to start with a carbonyl compound, an aldehyde or a ketone, and a secondary amine. Once you have your enamine, then we can react this with an alkyl halide. Now, an enamine is a moderate nucleophile, and it's just strong enough to attack an alkyl halide. We need to make sure we have a primary halide for these reactions. And it's the nitrogen on the alkene that pushes its electron density in. And that is nucleophilic enough to eject a halide. That gets us to, if you follow the arrows, this structure. Let's put our hydrogen on here. Sneak it in there. And there's our additional alkyl group, and the positive charge on nitrogen is offset by our bromide leaving group. This is called an iminium ion. And so this reaction, this is the product of this reaction. We actually get a charged species. Now, we don't see this too often, that we get a charged species, this N+, but we've seen it before. If you remember, anytime we attacked a carbonyl with a strong nucleophile, we are left with a strong, an O- intermediate, the tetrahedral intermediate. So we're not foreign to that, but this is a case where we have a charged intermediate. How we're going to finish this reaction, because we're not done at this stage, we're going to add water. And if you remember, by Le Chatelier's principle, anytime you form an enamine or an imine, if you have a lot of water present, you actually favor the starting materials in that reaction, which are the amine and the carbonyl compound. So we add water. We're going to do a hydrolysis. And before I get too much further, let's label this as an SN2 reaction with the halide. And once we do the hydrolysis, we actually get our ketone product back, and this is an alkylated ketone. You normally don't highlight it, but also we get the amine back through the hydrolysis. So if you're looking at where we started, which was with this ketone, versus where we finished, through enamines we can do carbonyl alkylations, at the alpha carbon. Now, we talked a lot about that in earlier videos. We talked about treating a carbonyl with LDA and making an enolate. We could react that with an alkyl halide. Probably the simplest way, but we talked about other approaches that use the Claisen condensation, approaches that use Wittig reactions to try to make exactly these kinds of products. And as it turns out, this reaction, when it was developed, the use of enamines to make alkylated carbonyls, it was a person named Gilbert Stork who developed this, and so this transformation was called the Stork enamine synthesis. And until people became comfortable with the chemistry of LDA, this was one of the primary ways to make alkylated ketones because they didn't have access to LDA. So really important reaction in organic chemistry.